Okay, so we've been talking about high availability. Um, One of the related concepts to high availability and fault tolerance is vMotion. What this actually allows us to do is to take a running VM from one ESXi host to another without any interruption whatsoever. And depending on how it works, you've essentially got it running on both systems at the same time. Um, and it's running on one system and running in the background on the other system, and the system transfers all control to the second. Um, you can move it, you can transfer control. Um, the thing about vMotion migration is that you don't have to do this in response to a failure of an ESXi host. It could also be done for the purposes of maintenance or upgrade or load balancing or to improve performance. Say, for example, you have a host that you know needs to come down for whatever reason. Um, and it's got some VMs on it doing some very important things. You move them all, you bring it down, you bring it back up, you move them back, or you don't, depending on what you need it to do. Now, in order to perform vMotion, you've got to have a port that is dedicated to vMotion, and they both have to have um, a common network switch and data store. So there's your vMotion network, and then your front side network, which is providing whatever services you need. There's a similar concept called storage vMotion. The difference between storage vMotion and VM vMotion is that it actually moves the VM from a data store to another, not from one ESXi host to another, but to um, a new data store entirely. There's a third category of, I think, a share nothing vMotion, in which the two systems have literally nothing in common. So it moves the data and it moves the VM, and it all happens. It's kind of like this. So you've got your data store in the SAN. You've got your vMotion network. You've got your VM1, ESXi host 1, ESXi host 2, and your vCenter server, which you will use to manage this process. This isn't possible with the free version of ESXi host and a simple vSphere client. You have to have vCenter server to move all this over, to manage this process. But you can basically tell it, hey, I want this VM to go from host 1 to host 2, and it will do the work. One of the things we can do, I mentioned DRS. DRS is the Distributed Resource Scheduler. You need a vCenter server for this. What it does essentially, as I mentioned before, you don't have to move these VMs as a response to some kind of outage. Or even necessarily, you could use this as a response to a degradation in performance that might predict an outage. But your DRS can use vMotion to balance your workload. It watches the cluster, it figures out if moving the VMs will be worth it, and then if it does, it will. There's a couple different modes that DRS can run. It can either do manual mode, automatic, or semi-automatic. You can set rules that will tell it if certain VMs on certain ESXi hosts need to be separated to increase redundancy. Imagine you're trying to build a cluster, and you've got a multiple ESXi hosts and multiple VMs. Say, for example, you've got you've built a cluster for a web server, and so you got a virtualized database server and a virtualized application server and a virtualized web server that's talking to those two things. And for the sake of maximum fault tolerance, you've got 3 ESXi hosts, and you've got your data store. And each of those is running on a different physical host. Now, if you put them all back on the same physical host, you've kind of removed some of your redundancy. So you can make sure that doesn't happen. Storage DRS can also, after vSphere 5, can also take advantage of storage tiering to use different speeds of storage devices. Say, for example, you've got your SSD, and you've got a SCSI drive that's spinning at 17,000 RPM. and you've got a you've got a SATA drive that's spinning at 7600 RPM. You could specify that, hey, for my really fast writes, I want to go straight to the SSD. And then I can write it to the really fast SCSI. And then I can write it to the slow SATA, like that. And then we've got our vSphere storage features. It would kind of look like this. This is so vMotion can move your data store between one data store and another within the SAN. And vMotion can also move the VM through the VM network. So your vMotion network will be talking to your vSAN in the back end. And that's how it works. Now the next thing we're going to talk about is virtual SANs themselves. So because this solution here is a physical SAN, but you can also virtualize it, as I mentioned before. We'll talk about that in just a minute.